morning. Today we are continuing with our unit on probability, and we are starting with CO74. I can calculate the probability of compound events. Remembering last week when we did CO73, that was calculating the probability of a single event. We had one event. What's the probability it's going to happen? I flip my coin. What's the probability I'm going to get heads? Yeah, because we took 1 out of 2. We had 2 outcomes, heads or tails. How many chances of getting heads? 1 chance. So 1 out of 2 was 50%. Now we're looking at compound events. Compound events are 2 or more events occurring. So now instead of it just being a single event, one outcome that, what are our possible outcomes? What are the desired outcomes? We have multiple events we have to look at. So to find the probability of a compound event, you want to find, so number 1, first step, find the probability of each event. So you have to look at what events you have happening. What is the probability of each of those events? Then you are going to multiply all the probabilities together. The probability of all the events happening is the product of each individual event. So product means multiply. Cameron, that does not sound like math. So you have your 2 steps. First one is the probability of each event. Then we want to find the product. We want to multiply each of those individual events, each of the probabilities, we multiply them together. That's the fractions. We're not multiplying the percentages, we multiply the fractions. So remember that probability is a fraction. Who remembers what's the numerator for our probability of a single event? So hint, look back at your last objective. What do we put on top? Go back one more, Ava. Ava?
Well, would you do 0% to 100%?
No, not that. What's the formula?
Oh.
Ava?
What you want to happen over what can happen, or desired outcomes, or the possible outcomes?
Yep, so we have what you want to happen, which is the same thing as desired outcomes, what you desire. That is over what could happen. Which is total possible outcomes. So what you want to happen over what can happen, all possible outcomes. Your desired outcomes over total possible. So you need to remember this. This is important for this objective. It's important for probability that we always remember what that probability formula is. What you want to happen or your desired outcomes over what can happen, what could possibly happen, which is the total possible outcomes. So let's scroll up and put this into action so we can see how to use this. So we have that bag of 20 marbles. In that bag of 20 marbles, 5 of those 20 marbles are blue, 8 of those 20 marbles are red, and 7 of those 20 marbles are white. So what is the probability of each of these things happening? So let's look at the first one. Choosing a blue marble, replacing it, then choosing a red marble. So what's my first step? So look back up. What was step number 1? Madison? Find the probability of each event. So what's my first event? The blue marble. What's my second event? Red. I always label my events so I don't forget any event. So it is important that you label each event that you are doing. Cameron, go sit back at the side table, please. Can you wait till I'm done? All the way on the side where Liam normally sits. Zelda, can you wait till we're done with practicing it together so you know what you're doing? So I always label each event that I have to do so I don't forget one and get the wrong answer. So I'm picking a blue marble, I'm picking a red marble. So now I'm going to look, what's my probability of choosing a blue marble? Using that formula, what is my numerator, what is my denominator? So going back to what we did in CO73, single event, remember we talked about the formula, desired outcome over total possible outcomes, Layla. So what is our denominator always? The bottom number is the total possible. So how many total possible outcomes are there? If I reach my hand in and I take out a marble, how many would that be, Melanie? 20. That total possible, there are 20 marbles. So there are total possible outcomes of 20 because there are 20 marbles. I'm wanting to pick a blue. So how many desired outcomes would that be? Bryn? 5. There are 5 blue marbles in there, so I have 5 chances of getting a blue marble. So now I need to look at my second event. Choosing, it's important to note that I replace it. Why is that important to note? Yeah, because if I didn't replace it, there would only be 19 marbles in the bag. But since I replaced it, I know that my total possible outcome stays the same. What's my numerator going to be? What's my desired possible outcomes? How did you get 8, Madison? There are 8 red marbles, so my desired outcome would be 8. That's my first step. I wrote down the events and those possible outcomes, the probabilities of each of those event outcomes. What's my step number 2, Zelda?
It's to multiply all probabilities together.
So I'm multiplying it. How do I multiply fractions? Nope. Ava?
Well, so the 20s are still the
Nope.
20s are.
That's adding and subtracting. The denominator stays the same, but we're multiplying, Dom. So I multiply across. So I have to do 5 times 8, which is what?
40.
Now Ava thought, well, we keep it at 20, but I said that's adding or subtracting. Your denominator stays the same. Melanie, what do I do?
I thought you did like the switch maybe like
You could cross simplify, or, oh, no, that's if you're dividing. If we're flipping division to multiplying, then we flip to our reciprocal fraction. But we're not dividing, we're already multiplying. So what do I do next, Connor? Nope, I already used my 5. I multiplied 5 times 8. Right? 20 times 20, I multiply straight across. 5 times 8 is 40. 20 times 20 is what? Now, what do I have to do, Claire? Because I need my decimal. So what is 40 divided by 400? So 40, you put 40 in first. 40, you always put the top number in first, then divide by the bottom number. Lauren, 0.1. Remembering, we want to turn this into a percentage. Is that 1%? Why would it be 10%, Marina? Because when we do percentages, what's our magic number? Yeah, we have to go out to our hundredths place. So we have to fill that 0 in. So our final answer is 10%. So what is the probability of choosing a blue marble, replacing it, then choosing a red marble? 10% probability. Let's do the next one. Now we want to choose same bag. We always start with this bag on top because all of these are having to do with those marbles. So same bag. What's the probability of choosing a red marble, not replacing it, then choosing a white marble? What is my first step? Ava?
Well, first, would you kind of like write down like red, and then you do 5 over 20, and then you do white, and then you do 7 over 20.
Okay, so, hey, hold on. Ava is right that we need to find our individual events, red and white, and we need to find the probability of each one. So probability of finding a red marble is 5 over 20 because there are 20 marbles in the bag. Some of us, as Ava was going through what she would do, caught that the direction said not replacing it. So if I have a bag with 20 marbles in it, I pick a marble out and I set it aside. Ava, how many marbles are left in my bag? 19. So now my total possible outcome changes. So when we see that not replacing it, it's important that we realize we have a new total possible outcome. Ah, so when we are doing it, what Ava did was she looked at our top outcomes and she went, oh, there's 5 out of 20, so this is 5 out of 20, but she didn't realize that was a blue marbles. So you always have to go back up to the top. Oopsie. So always go back up to that. It's the wrong button. All of my work just disappeared too. All right, so, oh goodness gracious, that's just going crazy on me. It is glitching on me. We need to go back up to that red and say there are 8 red marbles out of 20. Then we need to make sure we're looking at, so this is why, Ava, I label them, and then say, I need to make sure I'm looking at the red. I need to make sure I'm looking at the white. So when we take the time to label each event, makes you stop and think, okay, I'm not gonna just look at previous work I've done. I'm gonna really stop and think what my answers are. There are 7 white, now there are 19 in my bag. What is my next step? Raise your hands if you know what my next step is. Down. I need to multiply my events together. So how do I multiply my fractions? Down. I multiply straight across. 8 times 7 is 56. 20 times 19, 380. Now when I put this into my calculator for my next step, I need to remember that that fraction bar means divide. I always put that top number into my calculator first, then I hit the divide button, then I put in my bottom number. So 56 divided by 380. What decimal do I get, Tom? 0.147. Now remember what we said. What place do we round to? I'm glad you gave me that thousands place so we can talk about rounding. What place do I need to round to turn it into a percent? No, not the tenth place. What's our magic percent number? 100. So I need to round to my 100th place. In order to do that, I look at that thousands place. What is my rule for rounding, Madison? Yeah, if that number is 5 or higher, we round up 1. If it is 4 or less, it stays the same. So my 4 is followed by a 7. Is that 7 gonna make my 4 round up or round down or stay the same? It means I have to round up. It's higher than 5. So my number is 0.15. So what percent is that? 15%. Notice how I'm circling my percent. So with all of that work that I'm showing, I can easily find my final answer. But it is important that we round correctly. If you put 14% for this answer, it would be wrong. You must round correctly. Let's do our next one together. Choosing a blue marble, replacing it, then choosing a white marble. What's my first step? What's the first step I have to do? I need to figure out what my events are to find their probability. So I'm choosing a blue marble, and I'm choosing a white marble. So what is my fractions for the blue marble, replacing it, and then my white marble? What's the probability for the blue, Connor? What's the probability for a blue marble? 5 is not a probability. 5 is how many marbles blue marbles there are. What do I have to write? 5 over 20. You have to get that full fraction. So I replace the blue marble after I choose it. What is my probability for choosing a white marble? Claire? I replace it. So I put that blue marble back in. So I still have 20 marbles in my bag. So if we're replacing it, your denominator stays the same. If you do not replace it, it changes. So I found the probability fractions for each of my events. What's my second step, Lilia? I multiply across. So I have to say 5 times 7 is 35. 20 times 20 is 400. What decimal do I get? Down?
0.07.
0.087.
Oh yeah.
Oh, 87.
So I round to my hundredths place. So that 8 is followed by a 7. So what is my decimal going to be, Claire?
9.
It's just going to be 9?
No, it's gonna be 0.09.
0.09. Because it was followed by a 7, I need to round my hundredth place up.
So you just put the 0.
So your decimal is 0.09, and then you take that 10th and 100th place and you turn that into your percentage. So it is 9%. So our next one says choosing 2 blue marbles, not replacing either, then choosing a red marble. What are my events that I'm going to list? Melanie.
The blue and the red. So for the blue,
Hold on. So just blue and red? Do I have just 2 events happening? Why would it be 3, Callie?
It's just 2 blue marbles.
Because you have to choose 2 blue marbles. So those are each a separate event. So we choose a blue marble, then we choose another blue marble, then we choose a red marble. So we have to be careful that we're listing every event that's happening. So I am actually drawing from my bag 3 times. Picking a blue, then I reach back in, I pick another blue, then I reach back in and pick the red. So what are the probabilities of all 3 of those happening? Keeping in mind that we are not replacing marbles. Claire.
I'm confused because will you just do 5 2 times because or
Well, no, we have to think that one through. You're thinking it through, Claire. I love that. What is the probability of choosing our first blue marble? Yep.
5 over 20. So are we able to just double it?
No. Why can we not double it? Because, like Claire said, if I choose a blue marble and I don't replace it, how many blue marbles are left in my bag? So choosing a second blue marble, how many blue marbles are in the bag? If I picked a blue marble out and I set it aside, how many are left in my bag? 4. So now I have 4 possible blue marbles. And how many total possible are there? 19. Because I didn't replace my blue marble.
So if the original number is 5, but if you take 1 away, then it would be 19.
If we don't replace.
Yeah.
So you always have to check, am I replacing or not replacing?
Yeah.
The directions will tell you in the question. So what's my probability of choosing a red marble now? Lilia? 8, because there are still 8 red marbles in my bag. But Lilia's right, I didn't replace that second blue marble. So now it's only out of 18. So you need to find each event, then find the probability of each of those events, thinking it through. Am I replacing? Am I not replacing? How many are left in the bag? What's my last step? We have to multiply all of them. So I need to do 5 times 4 times 8. What is 5 times 4 times 8? Claire? 160. Now I need to multiply my denominators. 20 times 19 times 18. Claire?
6. Wait, 6,840.
6,840. Callie, what do I have to do next?
We divide the top by the bottom.
And what do I get? Did you do it yet?
Yeah, 0.023.
0.023.
Yeah.
So my 100th place is followed by a 3,
Can't add it.
so it stays the same because it's 4 or less. Madison, I don't need to be getting all those smells right now. Was that you that took out, or was that you, Brent? Somebody's taking out the smelly stuff. Remember, we're not putting hand sanitizer or lotions on in the middle of class. So, you're right, Claire. 0.02 is 2%. How are we feeling about this? Show me your thumbs. So remember, find how many events are happening, then find the single event occur probability of each of those events. What's the probability of picking a blue? I don't replace it. How does that affect my bag? Probability of picking another blue. I don't replace it. How does that affect my bag? And the probability of picking a red. And I multiply just like I multiplied when it was 2 events. Same thing I do with 3 events. Connor. Attention up here. Multiply across the top, multiply across the bottom, divide to find your decimal, turn it into your percentage. There. Sure. Because we do have a second page today. So I can go through one more. So this time, which is more likely? Choosing 4 red, not replacing any of them, or choosing 1 of each color, not replacing any of them. You put either, it should say any. So you're not replacing any of the marbles in either situation. So what do we have to do to solve this? We have 2 different things that we're finding the probability for. We have to find the probability for the top, then we have to find the probability for the bottom, and we have to see which one is a higher probability, which is more likely to happen. So how do I set up my first one? Choosing 4 red, not replacing any of them. How do I put that? Yeah, I would put red, 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 and red. But I'm not replacing. So my first red is 8, so 8 out of 20. What would my second red be? 7 out of 19. What's my third red? 6
out of 18.
And what's my last red?
5 out of 17.
And then I have to go through and I have to multiply them. Find the percentage. Then I have to do the same thing for choosing 1 of each color, not replacing them. Find your percentage. And then your answers, which one is more likely to happen, is a higher percentage. So I'm going to let you go through the work. I helped you with how to set up the top part. You have to figure out what the events are for that bottom part. And figure out your percentages. That last question, if you choose 2 marbles from the bag, replacing the first one, what is the least likely outcome? So you need to think it through. What would be the least likely thing to have happen? And I'm going to have you try to figure that out on your own. Our second page, let's look at what we're doing on that second page. This time, we have a spinner with 4 equal sections, red, green, blue, and yellow, and a die that is numbered 1 to 6. So we have a spinner and we have a dice. So what is the probability of spinning red, then rolling a 5? So how many events do I have happening? I love that I have some people's attention. I have other people trying to work ahead instead of following along with me. This is different than the bag of marbles. That's why I'm going through this first one together with us. How many events are happening right here?
I know. 5,
What is the probability of spinning a red
2,
and then rolling a 5? Was that you, Connor? What are my 2 events?
spinning 1, spinning red,
Spinning a red
and rolling
and rolling a 5. So I have 2 events that I have happening. What is the probability of spinning a red? How many red choices do I have on my spinner?
4,
How many red choices do I have on my spinner?
1.
I have 1 red spot out of 4 spots. So 1 desired red out of 4 total possible outcomes. Now my second event, I roll my dice. What's the probability I'm going to roll a 5? Lilia? 1 5 out of 6 possible choices. So I had to look at each event. Spinning a red, rolling a 5. Probability for spinning a red, there's 1 red spot out of 4 spots. There's 1 5 out of 6 numbers. What's my next step? I multiply. So 1 times 1 is 1. 4 times 6 is 24. So now I need to do what? Divide. And I get 0.04. And that is 4%. So you must first look how many events are there. So I label my events so I know what I'm looking for. How many reds are there on my spinner? How many possible choices are on the spinner? How many 5s are on my dice? Over how many numbers altogether are on my dice? Multiply, divide, and get your percentage. Okay, so you are going to work quietly on this. It is work time now. You can come and ask me questions. We will be correcting this tomorrow. If you are watching at home, I hope you are well, and I hope to see you soon. Have a wonderful day.